Hello, my name is Todd Evans, and I am a Level 2 Product Support Engineer at Cole Morgan. And this video series is an introduction to the AKD Ethernet IP servo drive. Welcome to video 4 of the AKD Ethernet IP video series. In this video, I will demonstrate how to configure, download, and start using the simple example program version 4.0. This will allow the first time user to do a bench test with their PLC in one AKD Ethernet IP drive and test drive it prior to the development of their application. This will provide insight into the use of the add-on instructions, how they control or interface to the drive and drive parameters, and demonstrate best practices for the implementation and triggering of each add-on instruction type. Once you've downloaded and extracted the zip file to a location on your PC, you can open up RSLogix 5000 or Studio 5000, and if you look in the add-on instruction zip file, you'll see that there is the simple example program for RSLogix 5000. So I'm going to open it up, and the first thing that happens is it says that the project's configured for a certain revision and so forth. So what I'm going to do is I'm going to change the controller, and I'm using a Compact Logix 5332E, which is a part number 1769 L32E. So I'm going to look for the L32E, and then in my case the software version is 20. You have to configure this to whatever applies to your software and firmware version of your controller, also the controller model number. I'll click on OK. It's going to convert the project and then open up. Now that we've selected the controller and the software version, there are only a couple of settings that need to change in order to use the sample project. You'll note that again that the PLC is my type and the revision number. And then also under Ethernet, if I double click on the Ethernet port local ENB, you'll notice that there's already an IP address in the sample project. So I'm going to have to change this so that it fits the convention of my network, which is a 192.168.0.x convention. You will need to set it up for what the PLC's IP address is set up for. So I'm going to change this. Okay, then I'm going to apply. Okay, so then the next thing that I need to do is I need to change the AKD that's been declared as a generic Ethernet module. I need to declare its IP address to be correct for the AKD, the target AKD that I'm going to run a bench test with. So I'm not going to get into all the different ways or details of how to connect to the drive. I'm going to just assume that you can connect to the drive at the moment. You'll notice it's the NBEI type here on the drive overview screen. And if I go to device settings, double click on communications, and I look at TCP IP, you notice that I've already configured this. You may already have it set up for rotary switches as a default, or you may be using the rotary switches, but more often than not, someone's system IP address does not follow the 192.168.0 format, so it's quite easy to just choose fixed IP address. At that point, you can change the IP address. Mine is already set up correctly, so I'm just going to leave it subnet mask. And I don't have a gateway, so you will set this up to what you need, and then you will apply, and then it will tell you that in order any kind of changes, of course, you need to save it or write to non-volatile memory, yes or no, and then you have to cycle the 24 volt logic power on the AKD so it boots up, and it will display on boot up your IP address or new IP address. So I'm gonna say no because this is already accurate. Sometimes it's also just as a good sanity check. You can right click on the Windows icon in the bottom left of your screen. You can say run, and you can type ping. So for starters, I'm going to say ping 192.168.0.5. Right click run. 192.168.3 for the PLC. So I have responses, so I know that the PC can see both devices, the PLC and the AKD drive. It's important that the PC is also configured for the same type of network. In my case, I have Ethernet connection properties, Internet Protocol version 4 properties. You notice the IP address follows the same first 3 octets, but then a unique last octet for the PC's IP address. Okay, so we verified we're online with the drive. We know what its IP address is, so let's go back to the Rockwell software, and I'm going to have to change this to 192.168.0 and 5, and I'm going to apply. And we're going to talk about the configuration of this later. Okay, so there's a couple things that I want to point out here. The name for the generic Ethernet module is AKD_1, but you can name it whatever you want in your application, but you have to give it a name. The COM format, when the project was created, was selected to be data.shortint, SINT. This is really important because we've already done this for you, but if you're creating your own project from scratch, or if you are working with an existing PLC program and you declare the Ethernet module, generic Ethernet module, you'll want to make sure that this is correct. This is also covered in the AKD Ethernet IP communication manual. You'll notice there's connection parameters. There's 64 bytes for the input or response assembly, 64 bytes for the command or output assembly, and then there's a configuration, 0 bytes, but this has to be declared. This is also in the AKD Ethernet IP communication manual. One other thing that's worth mentioning is the connection. If I click on the connection tab, the requested packet interval RPI, we've set it up for 40 milliseconds. This is because Workbench shares the communication bandwidth with the PLC and the AKD drive. So once the drive is commissioned, you can disconnect from Workbench. Then it may be possible to lower the RPI to 20 milliseconds, for example. Keep in mind that anything lower than 20 milliseconds will result in lost packets, timeouts, and erratic or lost Ethernet IP communications and behavior. Also note that the use unicast connection over Ethernet IP checkbox has been checked. This prevents broadcasting and will help with network traffic. Click OK, and we're ready to download the program to the PLC. You can save this if you would like before doing so. Click on the offline, download. Okay. There's no errors, and there's 2 warnings, but we don't have to get into that or worry about that. There's no errors. It compiled and downloaded just fine. So, once we're online, you'll notice that there is a green indicator lamp, IOOK. Now, you may have other Ethernet modules or other devices on the Ethernet link that your PLC is communicating with. So you may have a case where this is flashing or off or some other indication, and it could be not related to the AKD. But in this case, we have only one Ethernet device. In the case where this indicator lamp is flashing, then it may indicate that there is an issue with communications, which can range from cabling, IP addressing conflicts, other hardware issues such as Ethernet switches, routers, etc. If you don't have communications, make sure that you can ping both the PLC and AKD from your PC, as I demonstrated earlier. Also note there's a B1 button on the top of the AKD drive. If you press it quickly and release, then the current IP address of the drive will be displayed in sequence on the display in the front of the drive. This demonstration assumes prior to the PLC polling the AKD drive that Workbench has already been utilized to perform the basic setup of the drive, motor, and feedback. The drive is set for service and position in this demonstration. Note other command sources or operation modes may be used in the application, and it is possible to switch between them from the PLC. But in general, most applications that use the AKD Home, AKD Jog, and AKD Move add-on instructions have the drive set up for service position, which is assumed for this test. Other command sources and drive operation modes will be covered at a later time. Also note that the command source 1 field bus does not apply to Ethernet IP except in the rare case of using the AKD torque move add-on instruction that requires the drive to be in torque mode. Assuming everything is ready for the drive to be enabled, hardware enable, STO, basic drive setup, no faults, etc., the status bar at the bottom of Workbench should look as follows. Note that the drive is inactive. If you click on the enable disable screen, you will notice that everything is ready and green except this field bus enable is false. That is going to come over Ethernet IP from the PLC using the AKD enable add-on instruction. So now, assuming the drive is ready and the motor is ready to be enabled for this bench test, I'll scroll down. Rung 7, enable the drive. The AKD enable add-on instruction, and then there is a contact that I can toggle to enable the drive. So I will right click, toggle bit, it executed, it's done. So to verify that it did work correctly, I'll switch back to Workbench, and you can notice that the field bus enable is true and the power stage is on. Moving back to the PLC program, in the next run you'll notice that there's the AKD disable add-on instruction. In similar fashion as before, I'm going to toggle this contact. It's done, and I go back to Workbench. You'll notice the field bus enable is false and the power stage is off. So we now proven that the Ethernet IP communications from the PLC to the drive is working. So in the next video in this series, we'll go further with the sample project and demonstrate how to control the drive and generate motion from the PLC.